Okay, there we go. All right, so first, before I start off, how about a big round of applause for the Hacking Paris team? They've done an amazing job, I think, so far, and this is probably one of the best conferences I've ever been to. So in this talk, obviously, what you can infer from the title, we're going to be talking about enterprise security. And what I sort of want to do with this talk is maybe shed a different light on a subject and take a different perspective. When we approach the topic of information security in the InfoSec community, it comes most of the time with a lot of pessimism. And don't get me wrong, we really do have every right to be pessimistic about the subject, because as of right now, the state of just the regular old, the run-of-the-mill enterprise network is bad from any perspective that you look at it. So like from the human level to the virtual level, like it's usually just bad. Having said that, though, I think what my goal for this talk is to instill a sense of positivity and optimism, and to take a look at some of the tradecraft and tool sets that have been released over the course of the last decade that have sort of pushed the status quo forward to a point where modern versions of Active Directory, modern versions of the Windows operating system, both talking about Windows 10 and Windows 2016, are relatively secure. There is definitely room for improvement, as always, but I don't think anyone would argue that the new versions of Windows are relatively secure. So the obligatory who am I slide, I go by Byte Bleeder. I'm on the Twitters. That's my link to the GitHub. I'm the lead R&D researcher at Coalfire Labs. My thing is I build open source tools. I've been doing that for years now. I can't even remember when I was not doing that. And I also have a bunch of certs that really anyone cares about. So again, we're going to be talking about enterprise security. And it's a thing. It's big. It's a problem. And it's also sometimes extremely complicated. Now, I said that I wanted to instill a sense of optimism in this talk, but I'm going to start out the talk with a rant. So, because therapy is expensive in the States, and I need a way of just releasing my rage every once in a while. So, what are the challenges that the modern enterprise network faces? Well, they're huge networks. And scale is important, especially during pen tests and red teams. If you don't have tools that can automate post-exploitation tasks or even exploitation tasks at scale, because although we say we try to emulate adversaries as much as possible, we don't have infinite amount of time. We are constrained by our engagement window, so we need tools that can automate doing post-exploitation tasks at a large scale, because most of these networks are just huge. And a lot of times, this infrastructure is inherited from acquisitions. And this is a huge problem because there is nothing that gives you any indication that the information security program at the company that you're going to be acquiring or that you've acquired is up to the same par as your own. And sometimes there just isn't even an information security program. There's also usually a lack of visibility, inventory, and patch management, which all don't help when trying to secure large networks. There's also the age-old problem of security versus business continuity, right? Like you want to implement security in your environment, but at the end of the day, if people don't have the means of going about with their day-to-day job, security is meaningless. There's also usually limited budgets for security. Sometimes there is no budget for security. So which is why whenever I talk to people, I'm always a big advocate of using open source tools and maybe third-party Microsoft tools that you can use to secure your environment, because most people have a budget. And obviously, like big companies can enhance their security program by acquiring like big names, like big EDR names and stuff, but most people are really on a budget. Non-effective communication, this is another problem that I see all the time and we see at Coalfire, is that people come to us either because they just don't understand the risk in their environment, and there's usually a problem between communicating the risk from their internal IT staff to the C-level executives, right? And this is the same issues that we see with third-party consultancies as well. Like sometimes I see some pen testers come to me, and I know pen testers that just say, once you get domain admin, the test is over. Well, the problem is, if you say you got domain admin and present those findings to your C-level executives, they're going to say, cool, now can we move on, right? Because there really isn't, that doesn't really show them the risk that they have in their environment. But on the other hand, if you conduct post-exploitation activities and show them, hey, I got into your emails, I found your trade secrets, I found your customer's credit card data, that rings a bell, and they'll actually stop and listen to you. So it's just this whole big avalanche effect of just not communicating the risk properly. This is also another thing I see, like often companies invest in products, not people. And by that I mean, I like to call it the squirrel effect or the flashy blinky box effect, because people see these lights on boxes and they're like, oh, that looks fancy, I'm gonna put that on my network, and then the vendors tell them, yeah, sure, just put it there, and that fix all your hacker problems. The hackers will run scared from when they see this flashy blinky thing on the network. And it's the squirrel effect, because we see something flashy and it looks cool and stuff, and yeah, it might help your environment, but the thing is, if you don't have the people to configure that device properly, you're potentially opening up even more attack surface in your environment. So it really, you should invest in the people first and then enhance your security program with third-party vendor products. Legacy systems and applications, this is basically Microsoft's curse, it always has been. But again, it's getting better. So because of all these problems, if you talk to the pen testers, people that are in the trenches right now, they will tell you that this is your typical corporate network, right? It's a dumpster fire, because it really is just everything is just on fire, right? But I would like to argue that that's not realistic. I think that this is a more realistic representation of an enterprise network, because it really isn't just one dumpster fire, right? It's 12, it's 20, it's like everywhere in your network. A dumpster fire here, dumpster fire there. It's a little bit of everywhere. If you don't have a proper security program in place, things just really can get out of control really, really fast. So, like I said at the start of this talk, I want to instill a sense of optimism. So now that I got all my anger out, I want to try to instill a sense of optimism in this. And we're going to take a look at some of the tool sets and some of the tradecraft that has shaped the way that we really perform pen tests in Active Directory environments, and that have pushed the status quo, I think, to a whole new level where big companies like Microsoft have decided that, hey, we actually really do need to fix these problems. So we're going to start at the beginning, right? So this is the pre-PowerShell era. To be honest, I don't even remember what it was like before PowerShell became a thing. I don't know if it's because I've been trying to drink to forget that part of my life, but we really did have a lack of understanding. I personally think that the security community really didn't have a lot of in-depth knowledge about Active Directory and its inner workings. And it wasn't, and please correct me if I'm wrong, but I don't think it was like a topic that was really sexy. Like, it wasn't something that you could present to a conference and say, hey, look, I found this really cool Active Directory thing. And there was just a lack of knowledge on the subject, I think. And also lack of tooling. So we didn't have, like I said before, when it comes to large networks, we really didn't have tools that performed operation, like any type of offensive capabilities on large amounts of hosts. So we were in dire need of automating some of these tasks too. Like, we had basic tools that allowed us to query, for example, the members of the domain admin group, but we really didn't have a automated way of finding, for example, where the domain admins are logged in in the environment. And also, this was, the simple times where AVs were usually signature-based, meaning that you could probably just perform obfuscation on your binary, drop it to disk, and everything will be fine and dandy. And I mean, that sometimes works even now, but it was very much more the case back then. So these are some of the tools that I think have sort of shaped, like they were game changers even before PowerShell became a thing. And Mimikatz, SMB exec, and responder. So obviously Mimikatz, I think Benjamin is even here. I've never met him, but I don't think I need to tell anyone what Mimikatz is. SMB exec is sort of an initial attempt at automating post-exploitation and automating a credential theft on a large number of hosts at the same time. But the implementation was a little bit wonky. Responder, obviously, the ability to capture NTLM v2 hashes over the wire, or NTLM v1 hashes over the wire is a big deal by responding to those broadcast, multicast protocols. So these sort of started our understanding of like how Active Directory environments work and some of the protocols and some of the features of Windows operating systems that we really can abuse to perform penetration testing. And once these tools came out, there was this talk by Dave Kennedy at DEF CON 18, PowerShell OMFG, where he first introduced PowerShell to the security community. And after that, crap just hit the fan because there was just an insane amount of tooling after this that came out that allowed us to automate a bunch of tasks, especially when it comes to situational awareness. And it made things a lot easier for attackers to gain insight into the environment and to actually perform attacks and penetrate, like red teamers in penetration, to perform attacks in a limited engagement window. So that brings us to the present. And now, and my slide just jumped, so I'm just going to do that real quick. And now everything is PowerShell, right? So PowerShell. It's built into every Windows OS by default. Like before version 4 hit, there was no protections in it whatsoever, so you could just load scripts in memory that would bypass, at the time, that would bypass most antiviruses. It's extremely powerful because you could access the .NET dynamically without creating a binary. So the power in PowerShell comes from .NET and its access to the .NET runtime. And it really did have a bunch of features, quote unquote, that helped attackers in many ways. And needless to say, this was the dream, from a pen tester's perspective or a nightmare, depending on which side of the fence you are. But it really helped us push forward our knowledge on how Active Directory environment works as a whole. So after the security community but David Kennedy got the attention of to PowerShell to the security community, a bunch of other tools came out that, again, pushed the status quo even more. So PowerView and PowerSploit, Empire, Bloodhound, and SharpHound. So PowerView and PowerSploit are basically PowerShell implementations of conducting situational awareness. Find local admin access is amazing. Invoke User Hunter allows you to pinpoint exactly where the domain admins are logged in at. In a network. Empire, a pure implant C2 framework based on PowerShell. Bloodhound and SharpHound. SharpHound more recently is the C# ingester of Bloodhound. All these tools basically push the bar even more. And Bloodhound and SharpHound is amazing because it not only tells you where all the local admins, for example, are logged in at, but it tells you every single way that you could potentially compromise the Active Directory environment. So it's basically a nice GUI wrapped around PowerView with a little graph theory sprinkled on there, and it's amazing. If you've never tried SharpHound or Bloodhound, I highly recommend it. But the problem is, most of these tools, especially Bloodhound and SharpHound, are passive in the sense that they don't actively dump credentials, right? They don't actively compromise systems. So we need a way of we basically have to start back from the beginning. We need a way of performing post-exploitation tasks at scale. Because again, we have a limited engagement window. So how do we do that? Well, I took a stab at this problem, and I wrote crapmapexec. And basically what it is, it's a wrapper around the in-packet library. And this tool allows you basically to perform a bunch of post-exploitation tasks in large scale. You could potentially own an entire subnet in minutes. And I'm going to show you, I have a quick demo here, but really, I think I gave a couple of talks on CME, so CME alone could be a talk of its own, but it can do a lot more things than I'm about to show you here. So hopefully that's playing, and hopefully you can see. And is this there it is. So I'm going to sort of explain it to you in case The font is too small, and I apologize for that. But basically what we're doing here, we have Empire down here. We started up Empire with its RESTful API enabled. We have a listener running. And on top, what we're doing is we're telling CME to scan the 172 network, so an entire /24, or in this case, 4 hosts, just because it takes a little bit of time. And we give it the local administrator password. And we tell it to run the Empire exec module. And what this module does, since the whole framework is modular, what this will do is it'll connect to Empire and generate that one-liner PowerShell code that will basically give you a agent in Empire, right? So now we've essentially basically mass compromised, in this case, only 4 hosts, but you can do this on an entire subnet. Pro tip, after 255 agents, Empire gets really, really sluggish. So don't do that. And here we see now we have 4 agents from in Empire here. And now I'm just typo city, but I'm just trying to interact with one of the agents to show you that the sessions are alive. And this is just a subset of what CME can do. Like the most famous module probably is, again, the Mimikatz module, which allows you to basically mass spray Mimikatz on an entire /24 to dump clear text credentials in memory. Now, obviously, I'm not the first one who thought of this. There were other projects prior to CME that tried to do this. I think at one point there was even a invoke mass Mimikatz PowerShell script in the PowerSploit repo. I'm not sure if it's still there anymore, but I think at one point it was removed. There was also CredCrack and SMB map, which were previous attempts at doing this. What I did is just I implemented it a little bit better, added a bunch of other features, and integrated it tightly with the in-packet framework and added some concurrency to it. So obviously I'm not the first person to think of this, but this should give you an idea that now we're able to basically compromise systems and dump credentials on a mass scale. So if we're able to do this, why not automate the entire process, right? So these are 2 tools, Deathstar and GoFetch. Deathstar is basically my implementation of a tool that basically takes you from domain user to domain admin at a push of a button. Because we have all of the primitives necessary through Empire, through all the PowerShell tooling that's been coming out recently. We had all of the primitives necessary to do this. We just needed an implementation I guess a sane implementation that allowed us to go from a domain user on a network with no privileges whatsoever to a domain admin. And GoFetch is basically, my implementation uses Empire. GoFetch is basically an implementation using Bloodhound. And a colleague of mine, Dan McInerney, actually wrote Icebreaker. So what Deathstar and GoFetch don't do is give you a foothold, right? These are 2 tools that you run after you gained your initial foothold on the network. Icebreaker automates getting the foothold. So basically, at this point, we've just automated ourselves out of a job. But with Icebreaker, it combines a bunch of tools together, specifically like Responder and TLM RelayX, to automate getting that foothold. And then using Deathstar and GoFetch, you can automate the entire process of going from domain user to domain admin. So that's pretty crazy. And I'd like everyone to reflect about that, because in the span of 10 years, we've gone from not having tools necessary to perform just basic post-exploitation tasks all the way up to completely automating the entire process of pen testing an Active Directory network, to a point, obviously. And again, I just want to emphasize that once you get domain admin, that's not the end. That's the beginning, right? You're supposed to go in there and perform post-exploitation tasks manually, because that's where the actual value of a red team and a pen test is. But the thing is, on an average corporate environment, these 2 tools will get you domain admin, because the same misconfigurations and vulnerabilities are the same most of the time from enterprise network to enterprise network. So this is a demo of Deathstar. And again, I'm going to walk you through this because I think the font is a little bit too small. But basically, this is Empire right here. I'm just showing you that we created a listener. and we have no credentials in Empire's database. Right now, this is our VM that's connected to an Active Directory network. We're just verifying that the user, the current logged in user, does not have any special privileges whatsoever. So we see here, this is domain users group. It's only part of that group, so this user has 0 privileges on the network. So what we did there is we ran the one-liner PowerShell that basically gave us an agent in Empire. And once we have that initial agent in Empire, that's where Death Star takes over. And what we're doing here is we're running Death Star. The first thing that Death Star does is it performs recon in the environment. So it uses all of Empire's built-in modules, specifically here, PowerView, GetNet Domain Controller, Invoke User Hunter, to find where the domain controllers are at, and also where all the local, domain admins are logged into. Once it has that information, oh, and my screensaver just went. That's great. So let's go back to that. Once it has that information, I'm going to speed this up here because it does take a bit to gather that information. Once it knows who the domain admins are logged into, it'll start performing lateral movement. And it does this by basically first trying to elevate by bypassing UAC. In this case, we're just using the bypass UAC event viewer module in Empire, which takes advantage of the event viewer in Windows. And Enigma 03 found from SpectreOps found that you can use that to elevate and bypass UAC. And it'll find local admin access to check where on the network the current user has local admin privileges on. And if it does find that there are computers that it is able to move laterally to, it'll use WMI to perform those tasks. And in this case, we see here that we got a new agent already on a different computer. So it's starting the whole process of moving laterally. And the end result, I'm just going to skip by here real quick because it is a 5-minute video. The end result is that after moving laterally, after performing a domain privilege escalation via group policy preferences, so the password saved in group policy preferences, is that we find the username and password for the domain admin. So we automatically went from domain user to domain admin with just one simple script, which I think is pretty impressive considering that up until, again, like a decade ago, we didn't have tools to even find where the domain admins were logged into. So when I first released Death Star, I had a blog post, an accompanying blog post, and it was interesting because I thought, well, if I can write just like a 300-line Python script that does this, obviously, like, what do nation states have? That must be an awesome. They must have some awesome stuff that can do this, right? Well, 3 weeks later, NotPetya was a thing. And NotPetya basically used the same, not the same, but it used the same lateral movement technique. And I think it was the first ransomware that actually used WMI as lateral movement. So by showing you this, what I'm trying to point out is that this is something that's going to happen in the future. There's going to be more and more ransomware, malware that basically moves automatically, does lateral movement in your environment. It automatically basically does what Death Star does, only at a nation-state scale. So we've talked about where we are right now, but we have to talk about the future because Microsoft has put in place a bunch of defenses against these types of attacks, so AMSI being one of them. So if you notice, like if you try to run invoke Mimikatz on a Windows 10 machine, it won't work out of the box. So we have to talk about the near future and what we're doing as a community to sort of evade those protections and what the current trend seems to be. And it really does make sense because, after all, it is the attacker's creed, right? If defenses are put in place at one level, what you usually need to do to bypass them is just to go a level deeper, right? So, again, like I said before, the power in PowerShell usually comes from its dynamic access to the .NET CLR and DLR. So if we can find a way to access .NET without going through PowerShell, that would be a big deal because it would basically allow us to bypass all of those defenses and allow us to access the same functionality that all of this tooling has been providing without the, I guess, the pain from our part of getting by Windows Defender or other EDR solutions. So again, like the power in PowerShell comes from .NET. So can we do this through PowerShell? Well, this is a perfect example that, yes, we can. And a .NET to JS script is probably, is just mind-blowing. Like, I still don't understand how this works. I've tried and I can't, I really can't. But basically what this does is it allows you to load arbitrary .NET assemblies through JavaScript, meaning that with JavaScript, since there's by default, Windows machines come with, the Windows script host environment comes with a default JavaScript interpreter. With JavaScript, VB script, basically any type of scripting language that's supported by the Windows script host environment, you can load arbitrary .NET assemblies. So for example, with an HTA, you are able to just dynamically load .NET assemblies that inject shellcode, for example, or perform some of the actions that PowerView or maybe inject Mimikatz. You can reflectively load portable executable files, DLLs. And this is amazing because we're bypassing the need of accessing .NET through PowerShell, right? But the problem is that we've seen that the Windows script host environment is being locked down as well, right? There are protections that you can put in place to lock that down as well. And as a matter of fact, I think AMSI also flags right now, also by default flags the default .NET to JS scripts that it spits out. So there is a need to find a way to access .NET without going through PowerShell. And this is sort of my next project. This is like a sneak peek at my next project. What I'm trying to do right now is basically find a way to do exactly that, to dynamically access .NET without going through PowerShell. And this is my implementation of it. What we're seeing here is a C#, so a C# binary, so .NET assembly. And this C# .NET assembly basically embeds the IronPython engine. So IronPython, if you're aware of IronPython, it's basically Python implemented on top of the .NET framework. So it's tightly integrated with the .NET framework and can dynamically access CLR. And this is amazing because we can embed that engine within a C# binary, and we can automatically go from Python land to .NET land with a single .NET assembly. So we're calling Python here. So in this example, we just ran the binary, and it connected to our server. It what we're doing is we're telling it to load the platform module in Python. So it gives us the Windows operating system version of our compromised endpoint. We're telling it to basically import CLR, which is IronPython's way of interacting with .NET. Once we've imported CLR, we can add a reference to the system Windows forms library, and with that, we can pop a message box. So we've gone automatically from Python land to .NET with a single executable. And what's great about this is since this is a .NET assembly, it's very versatile. You can inject this without touching disk using .NET to JS, for example, or any other way that you can think of executing an arbitrary .NET assembly. And this is sort of my next project, and it's in the works. And I'm hoping that by end of this year, I'll be releasing it. I'm planning on open sourcing it anyway, so if you are interested in this kind of stuff, definitely catch me later. I'll be glad to talk about more in detail. And I just wanted to bring this talk to your attention as well. If this is something that you're interested in, and if you're interested in tradecraft and tooling that goes beyond PowerShell, I highly recommend this talk by OP Nomad that was given at Circle CityCon of this year. He basically gave a whole talk on how to quickly retool some of the tools that I've talked about so far in .NET and to basically get around all the PowerShell protections that I've been talking about so far. So I always try to find a way of sneaking mitigation details in here because at the end of the day, I've talked about like how we can hack all the things and break all the things, but I want to find a way of conveying this so that right after this talk, right now, if you're interested in actually if you notice that your security program is lacking, I want for you to use these slides as a reference so that maybe we can all up our game together in terms of defenses. So let's start with the basics. I can't believe I'm still saying this in 2018, but a lot of customers that come to me don't even have an account lockout policy in place. So if you don't have segmentation, if you don't have host isolation being extremely important, that's not something that I see almost at all. And inventory, that's a paddling. That's just the basics. If you do not have those in the environment, I highly recommend that you get working on that. SMB signing. This is something that I think is one of the most underrated security settings. I see a lot of guides on how to harden Active Directory and properly secure it, but SMB signing is sort of always mentioned as an afterthought, but it is a critical control because a combination with Responder and NTLM Relay X from the InPacket library allows you to basically dynamically relay SMB connections and compromise machines. So without going that extra step of actually cracking the NTLM v2 hash, you can dynamically just relay that hash to other machines on the network. So, and SMB signing prevents this because it digitally signs each SMB connection so that if it detects that if it's being tampered with, if there's a man in the middle, it will shut down that connection. So how do you go about enabling SMB signing? Well, you have to enable this registry key everywhere, and that's pretty easy. You just do that through group policy preferences. Obviously, these are all changes that you're probably going to have to test in a lab before actually deploying to your systems, just because it could break things. SMB signing in particular could cause additional overhead and could prevent legacy applications from working. So that's something that it's easy to enable, but it really could break stuff. And again, since enterprise networks all have usually legacy systems, that's something you're probably going to want to be aware of. Situational awareness. So this is sort of a problem because most of the ways that PowerView, for example, does situational awareness are considered features by Microsoft. And there really isn't a good way of stopping that. There are third-party products that implement deception technologies that have tried to tackle this problem, but quite frankly, I haven't had the experience with them, so I couldn't recommend any of them. And also, as I said before, usually enterprises have a limited budget, so they don't really have budget to spend $1 gazillion on buying these third-party products. So there are a bunch of ways, although there are a bunch of ways that you could probably, I haven't tested these myself, but it's from what customers have told me and from the recommendations that I gave them, specifically these, that they seem to at least solve some of the issues. Now, there's these two TechNet scripts, PowerShell scripts, from Itai Gradi, who also works on the Microsoft ATA team at their Threat Analytics, who basically found a way of hardening SAMR. And SAMR is the protocol that allows you to enumerate users and groups and all that kind of stuff, right, at a very high level. So with these two PowerShell scripts, you could potentially harden that protocol in order to prevent some of that situational awareness being gathered in your environment. And please, if anyone does really have any more pro tips on actually how to harden, especially when it comes to situational awareness, harden Active Directory for this, please let me know, because I'm always wanting to update these slides so I can just keep preaching these recommendations until I actually see them in enterprise environments. Domain priv-esc, Kerber roasting is all the rage, but quite frankly, I still find passwords and group policy preferences in sysvol. There really is no reason to Kerber roast if you could just find plain text passwords in those. And by plain text, I mean, obviously they're encrypted, but Microsoft released the private key to decrypt them. So it really is just plain text, and because of the nature of Active Directory, anyone can access the sysvol share. So how do you prevent this? Basically install that patch. And the problem is, once you install that patch, that patch won't actually delete those XML files in sysvol. So you actually have to go through sysvol yourself and find that cpassword attribute, the XML files that have the cpassword attribute, and manually delete those. So difficulty is easy to moderate. There's some effort that you have to put into it, but it doesn't really break stuff. Clear text passwords in memory, so Mimikatz. This is something that Windows 10 partially solved. I say partially because you can turn the wdigest LSASS feature back on with Windows 10. And not a lot of people know this, but there's this specific registry key that you can enable in Windows 10 that if you set it to 1, it'll basically restore those passwords in memory. And you could just log the user back, log the user off, and once it logs back in again, their passwords will be in memory even on a Windows 10 machine. So I personally always recommend that you have to install the patch that's been backported to Windows 2012 and to Windows 7. There's a patch that I think has been backported, and that registry key specifically should be monitored all the time, because if that registry key changes for any reason, you know there's malicious activity because attackers know about this little trick. And really, your administrators should have separate workstations. So they should have a workstation to perform their daily tasks and another separate workstation to perform their administration tasks. Local administrator accounts. Don't do this. So this is actually a screenshot from group policy preferences in a live client environment. These guys just gave local admin to everybody. Dev and test, domain users, infotech, everyone's domain admin. It's great. So you just compromise one local admin rather. So you just compromise one account, and now you have access to every machine in the environment. So everyone gets admin privs. It's awesome. This is a solved problem. Microsoft Laps basically takes this out of the equation. I say it's easy to install, but the reason why I put moderate here is you have to install it correctly, because if you misconfigure the permissions, since those local administrator passwords that are randomly generated get stored as Active Directory attributes to each computer, if you misconfigure those permissions, anyone can read the local administrator passwords of all the machines. So it just works. It doesn't break stuff, but just be careful about those permissions. So the conclusion is that we've managed to, like everyone in the community has managed to push this status quo to a level that big organizations like Microsoft have had to harden their security. And I hope I've instilled a sense of like confidence that we are actively changing, making things better for everyone. And I don't think the pessimistic approach to enterprise security, while it's still indeed there's a valid reason to be pessimistic about this. Like, I think there really is a sense of positivity that's been going on because of all the tool set and tradecraft that has been released that has sort of, again, pushed the status quo to a point where, by default, modern Windows operating systems are secure, are decently secure at least. And with that, I'm done. Are there any questions?
Hi, thanks for the cool talk. One question, is Destar providing a kind of reporting feature which says how it managed to escalate privileges or whatever, as a hint on how to protect that?
So is your question, does it provide a report? Is that like how it managed to?
Yep.
No, but no, it does not. But there's a blog, but the blog post that accompanied Destar detailed sort of the algorithm that it uses, and it does tell you like how, like in the output of the tool, it does tell you like how all the steps that it took, either lateral movement, domain priv-esc, and it tells you like what it found. So I guess it doesn't generate like a Word doc if that's what you're asking, but but the output of the tool sort of gives you an indication of like how it actually managed to get domain admin.
All right. Thank you.
Thank you. It's a very short question. The answer may be complicated. Thank you very much for all your tools that we are intensively using. During a recent red team operation, we had a lot of difficulties bypassing all the antivirus protection and security products protection.
Yeah.
In particular, with the products you mentioned, like Empire or CrackMac Exec, just to be sure, if I understood you correctly, do you expect that the .NET retooling would help
Yes.
completely bypassing
I mean, it would.
AIM-SI and...
It usually, so from my understanding of that talk is that, there's a link in the slide which I'll publish, but yes, it will help with that. And that's sort of the sneak peek to my next project that I'm calling Silent Trinity. It basically allows you to do that. So it basically allows you to dynamically access .NET without going through PowerShell at all. And I'm not talking about like creating an unmanaged PowerShell run space and executing PowerShell either in another process or in an unmanaged run space. I'm talking like direct access to .NET. So yeah, it would help because that just bypass. There is no, from my understanding, there's endgame CLR guard, which sort of attempts to block arbitrary .NET assemblies being loaded. But from my understanding, yeah, it would completely bypass like stuff like AMSI or script block logging or constrained language mode.
Thank you very much.
Hi. Do you think that the fact of automatizing attacks doesn't leave more footprints and more traces on the network?
Can you say it?
That you may be detected more easily if you do automatization.
Oh, do it automatically? Yeah, no, absolutely. So it depends, because in some enterprise networks, they have no visibility at all. So if you're coming to me saying, I mean, if it's a client if it's an enterprise that has at least some logging in place, and like if I ask them, hey, can you tell me like who logged into what system at this point in time? Like if they're able to tell me that, they would probably able to detect some of these attacks. But the thing is, again, like it varies so much that I cannot give you a yes or no answer on that.
Thank you.
Yeah, and if you have any more questions, please catch me outside and I'll be glad to answer them.
And following up on that last question, isn't the flip side of the coin that automation could potentially allow you to circumvent detection if you know what people are frequently looking for, and also gives you an advantage having run offensive practices in the past? I know that knowledge is a difficult thing to impart to new and junior employees, and automation is a way of imparting knowledge to them. I mean, many is the pen test that's been ruined by the junior employee who just goes crazy with Nmap, right? And so this is kind of a force multiplier for people in offensive practices.
Yeah, no, absolutely. Like if you're basing your detections only around automated tools, like you're doing it wrong. Like you should be thinking about, well, first of all, you should have an understanding of how the tools work in the first place, because if you don't have an understanding of that, then all your efforts are in vain. But if you're just basing your detections around automated tools, most of, I guess, your signatures or heuristics that you would put in place to detect these tools could be easily bypassed by just modifying a few lines of code, right? So that's why I always recommend like whitelisting, like products that application like Device Guard, App Locker, that kind of stuff, because whitelisting is probably the most effective way of blocking these attacks, in combination with like the new script block logging and all these protections that Microsoft has put in place. But yeah, no, absolutely, you're absolutely right. Yeah. Thank you.